Welcome to another video lecture. Today we will discuss about the analysis of cable when a UDL is applied over it. Here the video lecture will consist of two parts. In the first part we will discuss about the how to find out the horizontal thrust, then vertical reactions, then and also the tension values also. In the second part we will discuss about the how the when a load is applied over it, how the shape is going to happen. Then, and also we will discuss about the length of the cable, how to find out the length of the cable. So, let us begin the lesson. So, here 2 points A and B are given. That means these 2 points are supports. A and B are 2 supports are given. And the distance between these supports are small l. Okay, the distance between these 2 supports are small l. And here we can mark the capital H as horizontal thrust. Here PE as vertical reaction at point A and VB as vertical reaction at point B. And the total length of this UDL is small l. That means the distance between the supports. And again, when you are applying this UDL over this cable, there is a small dip going to happen at the center. That you can mark as small h. Then, the total length of the cable is given as capital L. These are some of the terminologies related with the cables. Okay. Then, you are going to analyze. And already discussed in the previous lectures that cable is very flexible. So the bending moment at any point will be 0. Okay. The bending moment at any point will be 0. So here we are going to consider the bending moment at the center point. If you are going to take the bending moment at the center point, what is going to happen? Before that, first of all, when this UDL is applied, what will be the total load? W per unit length is this magnitude. So the total force will be WL. So it is going to be shared equally. So the value will be WL by 2 at VA and VB. I hope how you got this WL by 2. Then our next aim is to find out this capital H, that is horizontal thrust. Here, if you are going to take the moment above this center portion, let us take this point as C. Okay, let us take the center point as C. So, if you are going to take this H over this, taking this moment about this point C, then what will be the value? It is in the anti-clockwise direction, so the value is going to be minus capital H into small h. Then this BA direction, BA is in the clockwise direction, so we can take down as WL by 2, the magnitude is WL by 2 multiplied by the total distance is half distance is L by 2, that is given here. Then here a small portion UDL is here, so the total magnitude will be W into L by 2 up to this much point. Okay, W into L by 2 and the half distance L by 2 half means L by 4. And when you are solving, you will finally get the horizontal thrust values WL square by 8h. This value is very important. Okay. For any exams, like PSC exams also this value, directly you have to by heart also this value. Directly you have to find out. If this dimensions small l and the dip and also the W value is given, then horizontal thrust you can find out easily. So WL square by 8h will be the horizontal thrust value. I hope the time how you find out this WL square by 8h. Then coming to how to analyze this tension over the cable. Let us take a small portion. And if you are taking this as our capital A point, and at any point there will be tension in the cable. So we can say that let us take a section X from the point A. And finally we will note down that there is a horizontal component here and here vertical component. So the resultant will be the tension. So that we can write down that T equals, resultant equals V square plus square root of V square plus H square. Okay. If you are considering this A point, there will be horizontal and vertical reactions perpendicularly. So, and we can know that this tension will be in the resultant. Tension will be in the resultant. So that we can write down as T equals V square root of V square plus H square. Then, there will be, if you are going to consider this V max means what? Maximum value of shear force. Where it is going to happen? Maximum value will be at the support. That means at A and at B. The maximum value of V will be at WL by 2 at support. Here, look at here. The value is WL by 2. As we are going to be coming down, the value will be decreasing. And at the center point, the V value will be 0. That is written here. V minimum equals 0 at the center. Have you got that value? Let us take the shear force. Here the value is WL by 2. And if you are considering the shear force here also, what is going to happen? W into L by 2 of this one. Let us take this one. Here WL by 2. And at this point we have to find out what is happening due to this UDL. W into L by 2. This is the shear force. So the value will be at the center will be 0. Okay. The value at the center will be 0. So V minimum equal to 0 at center and V max equal to WL by 2 at the support. Then our intention is to find out the maximum tension value. You can directly apply this values W for V equal to WL square whole square plus WL square by 8H whole square, and finally you will get WL by 2 into square root of 1 plus L square by 16H square. Okay. And the tension, minimum tension at the center will be only this horizontal thrust. Okay. So you have to by heart this values also, T max and T minimum. If you are given a problem directly, you can directly apply these equations and find out the values. Where is the maximum tension value and where is the minimum tension values, and also the horizontal thrust value. Okay, the rest of the things we will discuss in the next video. Okay, thank you.